I'm building an Arduino-powered Hexapod from scratch, and for the longest time, I've been using Blender to design the parts. That was a mistake for multiple reasons, and I finally did something about it. I redesigned the entire Hexapod in Fusion 360. I also printed them using a 3D printer from this video's sponsor, Ankermake. If you didn't know, my background is actually in game development, and to make the 3D models for my games, I used Blender. So naturally, I decided to design the Hexapod using Blender because it's what I was most familiar with. There were two main problems with it though. First, if I wanted to make a change to a part, I had to manually fix everything that it affected. There were multiple changes that I wanted to make, but I just didn't because of the amount of work it would have taken. Two, it just wasn't precise. I was doing everything by eye, and towards the end of the project, it was catching up with me. Every update I made felt risky. I knew I would have to stop using Blender eventually, but I didn't know what to switch to. Then I found Fusion 360. I had heard of it before, but I thought it was paid. I was wrong. In fact, it was the only mainstream CAD program with an unlimited free trial, which was a big deal to me. I didn't want people who buy the kit to be forced to pay for a CAD program just to use the files they bought. And I also didn't want to force people to use Blender. Ugh. So Fusion 360 was the perfect program for the job. My Blender problem was now solved, but there was a new problem. I didn't know how to use Fusion 360, like at all. The closest thing that I did know was SketchUp. So yeah, I was in for a great time. And before I get any comments, no, I can't just import the Blender models into Fusion 360. I mean, I could, but it would defeat the purpose of using a CAD program in the first place. I didn't know it at the time, but my decision to stream the entire process would be the reason I was able to finish it at all. I wanted to stream it because I figured the viewers would be able to help me out a bit, and the VODs might help others out as well. My first 11 hours over 2 streams, I was able to create the tibia support, and the servo mount. That was it. To my credit, I was making progress in learning, but I was making a critical mistake that, if I had kept going, would have made the entire project unusable. I wasn't constraining my sketches. For those of you who have no idea what I'm talking about, basically when you draw a sketch in Fusion 360, you can give the sketch measurements and rules called constraints. If you don't do this, and you make a change to a sketch, things will update unpredictably. If you do fully constrain your sketches, when you change parts of your design, the rest will update predictably. For example, let's say I want a longer femur. Because my design is fully constrained, when I update the femur length variable, the entire design updates to accommodate the change. So you're probably wondering, what made you realize you were making this mistake? But the answer's not a what, it's a who. Dusty, a literal Fusion 360 professional, was slowly losing his mind watching me butcher the program he uses daily. After he literally couldn't take it anymore, he not only hopped on a Discord call to help me out, the next day he joined my stream and gave a 3-hour-long Fusion 360 crash course on how he would go about making a Hexapod. And that is linked in the description. Dusty taught me the idea of creating a series of master sketches. These master sketches are fully constrained, and every part is made from at least one of them. If I needed to change a dimension, I could just change it in the master sketch, and the entire design would update appropriately. In 5 streams, 36 hours later, I had a brand new design. Barring the roll cage, because I still don't know what I want to do with that. Let me just show you how powerful the CAD Hexapod design actually is. All I have to do is change the dimensions, and the design magically updates. You can make it support bigger servos. You can make the coxa longer. You can make the femur longer. You can make the tibia longer. Any of you guys who watched my streams, and especially Dusty, thank you. I could not have done it without you guys. There are a couple notable differences of the new design compared to the old. One is the foot spring. It no longer has that awkward screw in the middle. Now there's just a single screw that goes all the way through the tibia and the foot spring. There's also some pins to keep it from rotating. Two is the bearing axle mount. It no longer awkwardly wraps around and just stacks nicely on top. Because of this, I'm able to have the bearing axle built in instead of it being a separate piece. 3 is the entire aesthetic of it. I went with a flat design with rounded corners. The entire design is significantly more unified now. Although, I do admit, I'll always be fond of the edginess of the old design. And 4, the upper frame is now a single piece, and the lower frame has the wire channels built in. I really hope you guys love this new design as much as I do. Now that the new design was done, I needed to print it, which is where the sponsor of this video comes in, Ankermake and their M5 printer. The M5 has everything you'd expect from an $800 printer. Super fast printing, and extremely sturdy construction. I cannot overstate how sturdy the construction is. Remote monitoring from your computer or phone, auto bed leveling, a flexible PEI magnetic sheet, a 4-inch touchscreen. Yeah, I know, it's a lot. It even has AI error detection. It uses the camera to compare the actual model to a simulated one, and if there's a big enough difference, it pauses your print and notifies you. Ankermake sent me the M5 in 8 rolls of their PLA Plus, so I can print my new Hexapod design with it and really put it to the test. This was the most securely packed thing I have ever received in my entire life. Honestly, unpacking it was more difficult than the assembly itself. To assemble, you just take off the bottom, attach the top, screw it up, plug it in, and you're done. For the very first print, I found this Harry Potter Ravenclaw bookmark. It was a pretty small print and had some very fine details. I figured this would be a good test, so I printed one on the normal speed setting and one on the fast speed setting. The normal took 21 minutes and printed literally perfectly. The fast one, however, took 17 minutes, so 4 minutes faster, but had a decent amount of under extrusion. So I figured I'd just stick with the normal speed setting for the time being. With my perfectly printed bookmark, I was feeling confident, so I started printing the Hexapod, specifically the frame bottom piece, which is the largest piece there is. I tossed the STL into the Ankermake slicer, added a 3mm brim, and started the print. 8 hours later, and the print was finished. There was slight layer shifting, but it won't have any impact on the functionality of the part. Overall, I am very happy with the quality. Next up was the frame top. I tried Prusa Slicer with this one, since the Ankermake Slicer is still in beta. I made the G-code in Prusa Slicer and was easily able to export it into the Ankermake Slicer. I ended up having a lot of bed adhesion issues with this one. After cleaning the bed, running the auto level, and adjusting the Z offset, I was able to get it to print, even with a shoddy first layer. And to be fair, it turned out great. I wanted to figure out this first layer issue once and for all, so I loaded up a first layer test print in the Ankermake Slicer and used it to find the perfect Z offset. Of course, it was already printing perfectly. I still tested other offsets as it went, but ultimately I started at 0.09 millimeters and ended at 0.1 millimeters. So now that I thought I had the first layer nailed down, it was time to print a leg. I didn't want to print all of the leg parts in bulk yet because I wanted to make sure a single leg fit together properly first. I started with all the white parts since that filament was already loaded. Once again, I threw the STLs in Prusa Slicer, generated the G-code, imported the G-code into the Ankermake Slicer, and started the print. And unsurprisingly, the first layer issues returned. Surprisingly, the white leg parts came out beautifully. I also got to inadvertently test the power loss protection after I accidentally bumped the power strip's power switch. I am happy to report, however, it works flawlessly. I now also had a very good idea of what the issue was. It was generating the G-code in the Prusa Slicer, which explains why the first layer of the bookmarks, frame bottom, and first layer test printed nicely, while the first layer of the frame top and white leg parts did not. I don't know exactly why it's happening. It must be like some sort of setting that's wrong or something, but a quick print of the foot tip confirmed my suspicion. When printing the foot tip from the G-code made in Prusa Slicer, the first 4 or so layers were horrible. When printing from the G-code made from the Ankermake Slicer, it would work literally perfectly. The new and improved workflow is plate the parts in Prusa Slicer, export the plate as an STL, import that STL into the Ankermake Slicer, and then print. I changed a bunch of settings in the Ankermake Slicer, most notably the initial layer speed, which I set to 30 millimeters per second. The entire parameter save file is linked in the description for anyone who wants exactly what I use. With the new workflow, it printed perfectly. And with the parts printed, it was time to put them together. It is always so nice when assembly goes well. And in this case, it did. Every piece was well within the acceptable tolerance of 0.1 millimeters, and I had no issues putting everything together. I did, however, have an issue with the design itself, specifically where the wire came out from the coxa servo. With how it was, the wire would scrape against the ground, and we don't want that. Fortunately, the fix was basically already done for me. All I had to do was extend an existing cutout so the wire could be channeled out a different way. I cut the existing piece with an X-Acto knife to confirm my fix would work. It did, and then I reassembled the leg. Fixing the design in Fusion 360 was as simple as extending the cutout all the way through. It was literally that easy. This new design is so clean. The foot springs in particular move like butter. I actually may have to make the springs tighter since there's basically no friction between the shaft and the spring, which is a testament to how good both Fusion 360 and the M5 are. Now that I knew the leg parts were good, it was time to print and assemble 5 more. Cue the montage. Here it is, the new Hexapod design. This should go without saying, but this is so much better than the first design. Overall, I was pleasantly surprised by how the printer held up, especially since initially I had some hesitations because it was a bed slinger instead of a Core XY. It got to the point where as long as the first layer printed well, I knew the print would succeed, which is the exact mindset you want to have with a 3D printer. If you want to learn more about the Ankermake M5, check out the link in the description. Thanks again to Ankermake for sponsoring this video. If you made it this far, hit the like button for me. It helps YouTube and me know if you actually liked the video, and I'm pretty sure you did. The next video will be on making the new design move. You may have noticed I'm using red servos instead of blue. The red ones are 3 times cheaper, $10 versus $30. And apparently they're just as strong and fast, but we'll see about that. I really hope you enjoyed the video, and I'll see you in the next one.